Yeah.
Sawyer's gone?
Tristan. We don't care about Tristan.
Oh, be nice. And this was recorded, so he might actually listen to it. All right, so real quick, I was just talking to the class, and we jumped ahead to 8-2, and this is on page 439. So if you're absent, this is what I want you to do. We're going to go over the lesson. I reminded everybody the area of a circle is pi r squared, and I talked about pi. For our purposes, just put down 3.14. You might have a calculator that has the symbol for pi, and if you plug that in, it's going to be 3.1415 dot. It'll keep going. And so that answer, if you plug in pi versus somebody just put it in 3.14, will be a little bit different. And I would just use 3.14, but if you want to use the symbol for pi, that's fine. Both will get. I'll be satisfied with the answer. So when you're figuring out the volume of cylinders, well, a volume of this would be pretty easy. You could just figure out the area of the base here, which is 24 inches by 24 inches, and then that's going to be multiplied by 48. Okay? Well, in this case here, it would be area of the base, or the top, whichever one, doesn't really matter, and it's going to be pi r squared. Well, what's r? R stands for, excuse me, allergies. R stands for radius, and so if you have a circle, remember from one side to the other is the diameter, and the radius is half the diameter. So it'd be 3.14 times the radius of any particular circle. In this one here, you can see it's 24 is the diameter, so the radius would be 12. So it'd be 3.14, times squared times pi. All right. So let's look at example 1. And that's what they're going over here. And they point out here that you can't really count the cubes because not all the cubes are a full cube. They're cut off because it's a circle here. And so it says use the formula to find the volume of the cylinder. Use 3.14 for pi. So volume equals the base times the height. Well, the base would be pi r squared, which we were just talking about that. And then whatever that answer is, it's multiplied by the height, which in this case is 48 inches. Okay? Let's look at the try it down at the bottom of the page. I did the first couple steps for you. It says the area of the base of the cylinder is 78.5 inches squared. So they've given us the base. Then it says, what's the volume of the cylinder? Well, so I put volume equals, or they've got volume equals BH. B would be the base. The base is 78.5. They gave it to us right here. Times 11. Where'd the 11 come from? The 11 is the height right here. And so 11, or 78.5 times 11 is going to equal something. And then it says the volume of the cylinder is something cubic inches. So I want you to fill out those two on your own. Scratch out the convince me. I'm not worried about that. Let's look at example 2. It says the volume of the juice can is 300 milliliters, which is equal to 300 cubic centimeters. What is the radius of the can? So they're having you find in these examples the volume, maybe the radius like they're asking here, maybe the height, maybe in some of them it might even be the diameter, which is twice the radius. So it says use the formula V equals BH. B is the base, and to find the radius of the can. Now they set theirs up a little differently, and with you guys I've done things a little differently than they do. But so we've got 300, that's the volume, equals pi r squared times 14. Where's the 14 coming from? That's the height. So equals, so I put 3.14 r squared. That's this part right here, times 14. So 3.14 times 14, or 3.14x, or pi times 14. You end up with 300, and it's being divided by 43.96. That's the pi r squared. And so I set it up. I didn't write the bottom part yet, but I put 300 equals 43.96 r squared. So we want to solve for, what are they asking? They're asking for the radius. So this is just like all these problems you've been doing for a few months where you're solving for x, except it's not x this time, it's r, and r stands for the radius. So I want to get r by itself, right? Yeah. So I'm going to divide what's happening to the r. It's being multiplied by 43.96. So I divide each side by 43.96. And what do you get? You get r squared by itself. And over here, you would have 6.82. I can even write it down here. So it would be 6.82 equals, or approximately, r squared. You're not done, though. Because we want to know what r is, not r squared. We want to know what r is. So you would just plug this in as a square root. Now, the calculators you guys have, they work two different ways. Sometimes you plug in the number and then you hit the square root symbol. On some of the calculators you have, you hit the square root symbol and then the number. It just depends on your calculator. But if you do it the correct way, if you figured out the square root of 6.82, and you'll get 2.6. Okay? So just remember, when we get to this, in some of these problems, you get to this last step, and you've got is approximately r squared, you're not done. You need to figure out the square root of that number. All right, example 3 here. It says safety barrels. You guys have seen these on the highways. These big yellow barrels are used on some highways to cushion car impact. If a city manager approves the purchase of 15 cubic meters of sand, how many barrels can be filled with sand? Use 3.14 for pi. So they go through the steps here for us. Volume equals the base times the height. So pi r squared is the base and times the height. And so the diameter of these barrels, they tell us right here, is 0.9 meters. Well, we don't want the diameter, we want the radius. So what's half of 0.9? 0.45. They've done that for us here. So it's going to be 0.45 squared and times 1.2. 1.2 is the height. And so you end up with 0.76302 meters cubed, because we're talking about volume. So you need to figure out how much, if one of these has that kind of volume, how many of these can we make with 15 cubic meters of sand? And the answer is, looks like it's 19.7. So they can make 19 of them. Almost 20.
Okay, so do you want us to write instead of 19.7, aspects like that is right, how many?
Yeah, what a good question. If it says to the nearest tenth, then just carry it one place.
But if it doesn't, then just
right.
19. Okay.
Sometimes it might phrase it, exactly how many barrels can you fill? And so then you would just say 19. All right. So to try it, I circled that one. It says Lynn is building a cylindrical planter with a base diameter of 15 inches. So here's the base. The diameter is 15 inches. What's the radius?
7.5.
Okay. She has 5,000 cubic inches of soil to fill her planter. What is the height of the largest planter she can build? Use 3.14 for pi and round to the nearest. There we go. This says the nearest inch, so no decimals.
Okay.
just the nearest whole inch. All right. So they give you the diameter. From there, you can get the radius. And you have 5,000 you can fill. So you're going to have to try to figure out how many she can build. What's the height of the largest planter she can build, actually? All right. Scratch out number 1. I'm not worried about that. This is on page 442. Number 2, it says, what 2 measurements do you need to know to find the volume of a cylinder? Well, height and radius. Number 3, well, they're having a lot of fun, sounds like. Number 3, it says cylinder A has a greater radius than cylinder B. Does cylinder A necessarily have a greater volume than cylinder B? Explain. Well, the answer is no, not necessarily, because if B is taller than A by enough, we don't know how much. That's really not the question. If B is taller than A by enough, then B could have a greater volume. You know, it's 3, 4, 5, 10 times taller. Even though it's really a small diameter, it still could end up holding more. Just like if I'd say my pen here was a cylinder, the diameter is, I don't know what, maybe ½ an inch, but it was 10 feet tall. And I put that right there. And then I wanted to compare how much this pen, which is really narrow but 10 feet tall, would hold compared to hers, her container here. You guys could figure that out.
Not the same.
All right. Okay, so circle 4, 5, and 6 on page 442. Page 443, what is the volume of a cylinder with a radius of 5 centimeters and a height of 2.5 centimeters? Use 3.14 for pi. So I did the first couple boxes for you here. 5 squared times 2.5. That'd be 25 times 2.5. And then fill out these 2 boxes here. For number 8, it says find the volume of each cylinder in terms of pi. So cylinder A has a base of 6 times pi feet squared and a height of 10. Cylinder B has a circumference of 6 times pi feet, and the height is 6 feet. Remember circumference? Circumference is the if I had a circle here and I measured how far around, I'm measuring the outside. Okay? Circumference is different from diameter, which is different from radius. Circumference is measuring how far around. All right, circle 10 and 11A and B. It says use a figure at the right here. So they give us the radius. Looks like it's 4 inches. The height's 3 inches. So find the volume. And then B, it says, is the volume of the cylinder, which has the same radius but twice the height, greater or less than the original cylinder? This is the original cylinder. So they're giving you something that a different cylinder to consider. Is the volume of a cylinder which has the same radius but twice the height greater or less than the original cylinder? Well, it's kind of a no-brainer. And then number 12, a rectangular piece of cardboard with dimensions of 6 inches by 8 inches is used to make the curved side of a cylinder-shaped container. Using this cardboard, what is the greatest volume the cylinder can hold? When you're limited to these dimensions here, what's the greatest volume of water or whatever, air, who knows, that it can hold? And I scratched out explain.
Yay!
13. Circle A, scratch out B. 14, 15, 16, 17, and 18. So that's it. So, like I said, I'm kind of guessing that you'll have some questions on volume of cylinders on the test next week. We'll see.